Usually, good digital design is invisible.
Right. Totally invisible.
Yeah, it's this philosophy of like total frictionless smoothness. You hold a pane of glass in your hand, you tap a glowing rectangle, and a car just shows up at your door.
Or you just swipe your thumb left and an annoying email completely vanishes.
Exactly. The entire tech industry has basically trained us to believe that the ultimate goal of any user interface is to remove all barriers between you and your immediate desire.
Yeah, it's all about supreme comfort, absolute convenience.
Which is, a beautiful philosophy if you're building a consumer app.
Oh, for sure. But take that exact same frictionless mindset, drop it into the control room of a chemical refinery or like the dashboard of a surgical life support system.
Yeah, you do not get convenience there.
No, you get a catastrophic disaster.
And that completely flips the script on everything we think we know about digital design. So welcome to today's deep dive.
Glad to be here.
We're jumping straight into a profoundly different universe today. We're exploring a really fascinating 2026 article, and it's titled User Research in Industrial and Safety Critical Environments.
Right, by Tobias Reidenhack.
Yes, the head of design at Intunio, which is a digital design studio out of Gothenburg, Sweden.
It's such a great piece.
It really is. Our mission for you today is to look at what happens when design stops being about getting your groceries delivered faster and starts being about absolute reliability, safety, and raw survival.
Because the central thesis here is that designing for these high-stakes industrial environments forces us to completely invert the traditional rules of user experience, or UX.
It's a total paradigm shift.
Exactly.
Bye.
Because, think about it. When a designer places a button in the wrong spot on a social media app, maybe a user accidentally mutes a friend.
Annoying, but fine.
Right. But when a designer makes that exact same mistake on a power grid control system, a city goes dark.
Okay, let's unpack this. Because to truly grasp Tobias Reidenhag's research, we have to deeply understand the context these users are operating in.
Yeah, context is everything here.
So imagine you are using a food delivery app. The user interface is a bit clunky, the menus are confusing, and you accidentally order a pepperoni pizza instead of mushroom.
Tragic, but survivable.
Right. The worst case scenario is your dinner is ruined, you leave a bad review, and you order something else. Now, contrast that entirely low-stakes environment with an industrial manufacturing plant.
It's a whole different ballgame.
You have a technician operating a multi-ton robotic arm. If the interface on their control panel fails to communicate a pressure spike clearly, or, buries an emergency shutoff under 2 layers of submenus.
The consequence isn't a bad Yelp review.
No. It is a severed limb, a massive chemical spill, or millions of dollars in destroyed machinery.
And the physical and psychological reality of that technician is just miles away from the person ordering pizza on their couch.
How so? Like, physically?
Well, in these industrial environments, users are bound by incredibly strict physical limitations. They're operating under intense time pressure.
Right.
Often with alarms blaring in the background or heavy machinery literally vibrating beneath their feet.
Yeah.
They carry this massive weight of responsibility.
And they aren't just casually browsing a single screen either.
No, not at all.
They're synthesizing data from multiple monitors while talking over a radio and watching a physical machine on the factory floor all at the same time.
And that changes the entire definition of what a good interface even is. Reidenhag emphasizes that in these environments, aesthetics simply do not matter.
They don't care if it looks pretty.
Exactly. A sleek, beautiful, minimalist screen is completely useless if it doesn't give the operator the right data at the exact right millisecond.
Timing is everything.
Success here is dictated by the timing of the information. It's about the rigid order in which critical decisions have to be made.
So it's about flow.
Yes, and pacing. Because if a crisis hits and the system floods the operator with 50 flashing warning lights all at once.
Oh, wow, yeah. Cognitive overload.
Right, cognitive overload kicks in, the operator freezes. But on the flip side, if the system hides too much information just to look clean,
the operator is forced to make blind choices.
Potentially disastrous choices.
So the environment completely dictates the interface. You really cannot design the screen until you understand the noise, the heat, and the stress of the room the screen sits in.
You have to live in their world first.
Which brings up something I've genuinely struggled to understand about this whole process.
What's that?
Well, if the stakes are this high, and the operators are these highly trained, Experts, people who have spent years mastering this machinery.
Right, true experts.
Wait, shouldn't we just be able to put them in a lab, interview them, and ask them exactly what they want? Can't a design team just invite a few veteran operators into a quiet, comfortable lab, buy them a coffee, and say, walk me through exactly how you want this dashboard to look?
I mean, it seems like the most logical approach in the world, right? If you want to build a tool for an expert, just ask the expert to describe it. But the source material makes a really compelling case that this classic, interview-heavy UX methodology completely breaks down when applied to industrial settings.
Really? Why does it break down?
Because traditional UX research assumes you're building something like a banking app. It assumes the user interacts with the software frequently, maybe 10 times a day, for very short sessions.
And the risk of failure is practically zero.
Exactly. You're highly practiced at a very simple, low-stakes task.
Right.
But an industrial operator's reality is the exact inverse of that.
Give me an example.
Okay, take something like an emergency cooling override protocol on a chemical reactor.
Sounds intense.
It is. The operator might only need to use that specific digital interface once every 2 years.
Oh, wow. Once every 2 years.
Yeah. But when that moment comes, the interface must be instantly comprehensible, and it has to work flawlessly on the very first attempt.
Because there's absolutely no room for a learning curve or trial and error.
None. Zero. Furthermore, these users are experts at chemistry or mechanical engineering, not necessarily experts at articulating digital software needs.
Still, if they know the machinery inside and out, why does putting them in a pristine usability lab fail? Like, why can't they just sit down and explain their workflow?
Because expert knowledge often becomes completely invisible to the expert.
What do you mean by invisible?
Well, if you put an operator in a quiet lab, they can easily recite the official step-by-step manual for handling a pressure drop.
Sure, they've memorized it.
Right, they'll tell the researcher, I press button A, then I adjust slider B. But what they usually cannot articulate is how they actually survive a real chaotic event on the factory floor.
Ah, because the lab is too sterile.
Exactly. In that sterile lab, they're disconnected from the actual environmental triggers they rely on.
Right, they don't have the context.
They might not realize that in reality, they only know when to pull slider B because they can literally feel the floor vibrating at a specific frequency.
Oh, that's wild.
Or because they use their peripheral vision to check a physical gauge across the room while they're typing.
So they've built up all this muscle memory and all these subconscious environmental cues.
Yeah.
And the moment you pull them out of the factory, those cues just vanish.
The lab strips away the very context
Yeah.
that determines whether the interface will actually save the day or cause a meltdown.
Here's where it gets really interesting.
Oh, absolutely.
Because if the pristine lab environment is useless and simply asking the experts to design their own tools doesn't work, designers are left with this massive, dangerous blind spot.
A huge gap.
There is a vast gap between what these highly trained operators say they do in a sterile interview and what they actually do when they're out in the wild, covered in grease, trying to keep a production line from crashing.
What's fascinating here is how industrial UX researchers must evolve to navigate that specific gap.
How do they do it?
Reidenhag points out that reading internal requirement documents or, conducting whiteboard sessions
Yeah.
rarely captures reality.
It's too theoretical.
Way too theoretical.
Oh.
Instead, researchers essentially have to become field anthropologists.
Field anthropologists. I love that.
They must prioritize deep workflow analysis and direct on-the-ground observation. They literally have to put on the hard hats, get out onto the factory floor, and shadow the operators during real shifts.
They have to see the messiness of the job firsthand, but what exactly are they looking for when they're standing out there with a notebook?
They're hunting for behavioral cues that never, ever make it into a formal spec sheet.
Like what?
For example, a researcher might notice that every single morning, the moment a technician logs into the control terminal, they immediately close the default dashboard.
Okay.
And then they manually open 3 obscure submenus, dragging them to the center of the screen.
Every single day.
Every day.
Yeah.
So the researcher has to ask, why? What critical piece of daily information is the default view failing to provide?
Right, forcing this operator to spend 2 minutes hacking their own workspace every single day. I mean, picture yourself having to do that at your own job. Bypassing an annoying security prompt or ignoring a glitchy software warning just to hit a deadline. We all do it.
We absolutely do.
Now multiply that urge to find a shortcut by 1,000 because an entire manufacturing line is waiting on you.
And that leads to the most critical thing researchers look for. Dangerous workarounds.
Dangerous workarounds.
Yeah. If a researcher observes an operator routinely bypassing a critical safety protocol, maybe they tape over a warning sensor or they memorize a keystroke sequence to rapidly dismiss an alarm without even reading it.
Management would probably freak out.
Oh, the instinct of management is almost always to punish the operator for being reckless.
Right. Blame the user.
But the UX researcher views it entirely differently. They recognize that if an expert is taking a dangerous shortcut, it is almost always because the interface is so poorly designed that doing the job safely is impossibly slow or frustrating.
The shortcut isn't a training failure.
Not at all.
It is a symptom of a failed design. The UI is literally forcing the operator to act unsafely just to keep up with their quota.
And you cannot uncover that dynamic in a conference room.
No way.
You have to be on the floor watching the operator sweat under the pressure of keeping production moving to really understand how profound uncertainty and intense stress warp their decision-making process.
So the researchers spend weeks on the factory floor. They observe the noise, the stress, the hidden shortcuts, and the bizarre workarounds.
Gathering a mountain of data.
Right, this mountain of incredibly complex, messy data. And I think the natural instinct for any modern digital designer looking at all that chaos is to say, this is way too complicated. We need to clean this up. Let's simplify.
Well, it's the strongest instinct they have.
Yeah, we want to apply that consumer smartphone logic and just dumb it down to make the screen look friendly and minimal.
But in the industrial space, falling for that instinct is one of the most dangerous mistakes a design team can make.
Think about a master mechanic's massive toolbox in a bustling auto shop. You know, you've seen these things. Heavy metal, standing 6 feet tall, dozens of drawers, packed with hundreds of highly specialized ratchets, torque wrenches, and pneumatic tools.
Very intimidating to look at.
Totally. To an outsider, it looks chaotic and overwhelming. Now imagine a slick digital designer walks into that garage and says, this is too complex. We need to simplify your user experience.
Oh, no.
So they throw away 90% of the specialized tools and leave the mechanic with a beautifully sleek, minimalist white box containing exactly one hammer and a flathead screwdriver.
That mechanic could be completely paralyzed.
Right.
They couldn't rebuild an engine with a hammer and a screwdriver, no matter how elegant the toolbox looks.
You wouldn't throw away the highly specialized tools just to make the garage look cleaner. You would keep every single tool, but you would organize them flawlessly.
Yes, organization over elimination.
You would make sure the 10mm socket is exactly where the mechanic's hand naturally reaches when they're under the hood and the engine block is hot.
That concept translates perfectly to the digital interfaces Reidenhag discusses. The author explicitly states that good industrial UX is rarely about simplifying a system by deleting features.
Because the environment is inherently complex.
Exactly. The reality of the physics, the chemistry, and the heavy machinery these operators are controlling is inherently undeniably complex. The system contains countless parameters, pressure gauges, and temperature settings for a very good reason.
The complexity isn't a flaw.
No.
The complexity is the job itself.
The goal of the designer is not to remove that complexity, but to structure it. It's about organizing that massive digital toolbox so the operator's cognitive load is managed.
So how do they do that?
This is where designers rely on creating really clear mental models.
Okay, explain how that works in practice. How do you map a digital screen to a physical machine?
Well, a mental model is simply how a user intuitively expects a system to behave based on their understanding of the real world.
Makes sense.
So if the operator knows that physical fluid flows from tank A on the left through a pipe into tank B on the right,
The digital interface needs to reflect that.
yes.
Yeah.
It needs to visually represent that exact left-to-right spatial relationship.
What happens if it doesn't?
If the digital interface lists tank B above tank A in a drop-down menu, it breaks the operator's mental model.
Oh, I see.
Their brain has to pause,
Yeah.
translate the digital menu into the physical reality, and then make a decision.
And in an emergency, that 2-second cognitive pause can be catastrophic.
Exactly. But when the interface perfectly matches the operator's mental model, they can handle an immense amount of necessary complexity safely.
But surely not every single dial and readout on these legacy systems is strictly necessary. I mean, some of that complexity has to be useless clutter, right?
Oh, absolutely. And separating the necessary complexity from the useless clutter is the ultimate analytical challenge for the researcher.
How do they tell the difference?
They have to identify what Reidenhag calls Historical or technical debt.
Meaning things that only exist on the screen because that is how we built it 15 years ago.
Precisely. Or things that exist because of internal corporate politics.
Politics,
Oh,
really?
yeah. Imagine two engineering teams a decade ago. Team A wanted a digital pressure gauge on the main screen. Team B wanted a manual toggle switch.
Let me guess. They argued, compromised, and management just crammed both onto the dashboard to keep everyone happy.
You nailed it. And now, in 2026, a new operator is staring at a cluttered screen, paying the cognitive price for a boardroom compromise made 10 years before they were even hired.
That is wild.
The UX researcher's job is to ruthlessly strip away that historical debt while fiercely protecting the highly specialized wrenches the expert actually relies on.
So what does this all mean? When we talk about structuring this massive amount of complex information and mapping it to the operator's brain, we inevitably collide with the physical reality of the environment.
We do.
And this forces us to completely redefine a concept that gets talked about a lot in modern design: accessibility.
Right. Accessibility takes on a whole new meaning here.
Normally, when we hear accessibility, we think of adding a screen reader option or ensuring a website has large text for someone with a visual impairment.
The standard compliance stuff.
Right, but in the industrial world, the physical realities mentioned in the source material paint a wildly different, much more aggressive picture of what accessibility actually is.
It's way more extreme.
Picture yourself standing in an outdoor refinery. You are trying to read a critical warning message on a tablet, but the midday sun is creating a blinding glare on the glass.
Or you're in a pitch-black, windowless maritime control room trying not to ruin your night vision while reading a monitor.
Yeah. Or you're wearing thick, heavy, flame-retardant gloves, and you need to interact with a touch screen to stop a pump from overflowing.
And if you misclick because your glove is too thick,
Or you misread the warning because of the glare.
the machine breaks.
Mhm.
If we connect this to the bigger picture, in the realm of industrial UX, accessibility is absolutely not just an HR box to check for inclusion at the end of a software build.
It's not an afterthought.
It is not a separate compliance requirement. In this high-stakes world, accessibility is synonymous with raw quality and operational robustness.
The environment itself acts as the impairment.
That is the core insight. Every single user in an industrial setting is temporarily impaired by their environment.
Wow, that's a great way to put it.
Whether it's deafening noise drowning out an audio alarm, thick clothing restricting their dexterity, or sheer panic degrading their cognitive processing speed.
So the design has to compensate for all of that.
Yes. When Reidenhag's article argues for high readability, stark visual contrasts, and large predictable touch targets, it is not for aesthetic minimalism.
It's not a design trend.
No, it is to guarantee that the system remains safely operable when the environment goes to hell.
The design has to be robust enough to physically cut through the noise, the glare, and the grease. It has to survive the messy reality, not just look good on a monitor in a perfectly lit design studio.
And we have to remember the sheer lifespan of these systems, too.
That's a good point.
We are so conditioned by the consumer tech cycle, where a smartphone app gets an update every 2 weeks and a website undergoes a total visual redesign every year.
Right, we're used to constant refreshes.
But when you're building the control architecture for a municipal water treatment plant or the interface for a robotic automotive assembly line, that software might not get replaced for 20 or 30 years.
So the digital interface will literally outlive the careers of the people who designed it.
Exactly. Multiple generations of hardware and multiple generations of human operators will be constrained by the decisions a single UX research team makes today.
That is a staggering amount of pressure.
It is. User research in this context isn't about gathering quick insights to boost next quarter's user engagement metrics.
No, it's way bigger than that.
It is about reducing systemic long-term risk. It's about building incredibly stable foundational assumptions that will guide engineering teams for decades.
It really reframes the entire profession. Like, these designers aren't digital decorators making things look pretty.
Not at all.
They are architects of human behavior in life or death situations.
Ultimately, as the article concludes, conducting user research in safety-critical environments boils down to deeply understanding human responsibility.
Yeah.
It requires designers to truly grasp the profound, real-world consequences of the decisions these operators make every single shift.
They have to feel that weight.
Right. When a design team truly internalizes the weight of that responsibility, they stop building for convenience and they start building systems that are genuinely reliable, robust, and safe, even under the absolute worst conditions imaginable.
We have covered incredible ground today.
It's been a journey.
We started by challenging the assumption that digital design should always be frictionless and easy. We stepped into the high-stakes reality of industrial control rooms, where a bad interface can lead to catastrophic failure.
Real consequences.
Yeah. We saw why bringing an expert into a pristine lab fails to capture the chaotic sensory reality of their actual job, and how researchers have to hit the factory floor to find those hidden, dangerous workarounds.
Becoming field anthropologists.
Exactly. We learned that complexity isn't the enemy. You don't throw away the mechanics' tools, you structure them to match their mental model while clearing out decades of inherited historical debt.
Structuring the chaos.
And finally, we saw how extreme physical environments turn the concept of accessibility into a matter of raw survival and generational robustness. We want to thank you for joining us as we explored this intense, largely invisible world of safety-critical design.
It really is a hidden layer of engineering that hums away in the background, keeping our cities powered, our factories running, and our modern infrastructure safe.
And as we close out today's deep dive, I want to turn the lens back onto your own daily life.
Oh, this is a good thought experiment.
Think about the complex software, the convoluted internal portals, or the legacy systems you are forced to use at your own job every single day. The ones that constantly frustrate you or force you to use weird workarounds.
Well, I'll have them.
Look closely at them tomorrow morning. Ask yourself, how much of that on-screen complexity is actually an essential, specialized tool you need to do your work? And how much of it is just inherited historical debt? A boardroom compromise from 10 years ago that no one has bothered to clean up.
Such a great question.
Keep an eye out for it. Recognizing the difference might just change how you view your entire workflow. Until next time, keep diving deep.